Okay, folks, in this video, we're looking at how to add matrices, specifically a 2 by 2 matrix. Okay, now matrix here, just a fancy way of saying like an array of numbers, okay, so a list of numbers. So usually n by n, okay. So think of it here as in this case here, like a 2 by 2, like column vector, okay, if that helps you. You're going to add your top commodity here. So we're going to matrix A, which is 3 minus 2 minus 5 and 1, and matrix B is minus 2 minus 4 minus 4 and 2, and that's to calculate A plus B. So all we do is we're going to add our top components. We're going to have 3 plus minus 2, then we're going to have minus 2 plus minus 4. Then we're going to have minus 5 plus minus 4. And then finally we have 1 plus 2. Okay, so be careful here with your negatives here, okay, because it is a non-calculator paper. 3 plus minus 2 is 3 minus 2, which is 1. Minus 2 plus minus 4 is minus 2 minus 4, which is minus 6. Minus 5 plus minus 4 is minus 5 minus 4, which is minus 9 or negative 9. Then I've got 1 plus 2 or 1 add 2 is 3. So the final answer reads 1 minus 6 minus 9 and 3. Okay, so we are adding here a 2 by 2 matrix. Okay, so whenever you're adding and subtracting, okay, you must have the same, okay, in this case, n by n, okay, and m by m. Okay, it must be equal. Okay, so in this case, n has to equal to m whenever you're adding or subtracting with matrices. If you're multiplying, it's slightly different. Okay, whenever you're adding and subtracting matrices, okay, you must have here the same. Okay, same number of columns as you do rows. Okay, so this one here is a 2 by 2 matrix. It's 2 across and then 2 down. Okay. So yeah, that is why it's a 2 by 2 matrix. We say it's a 2 by 2 matrix, and a matrix here is just an array, a list of numbers in this format. Okay, so you have, let's say, A, B, C, D, and I can obviously extend it if I want to. I can put E, F, I can put Z, okay, X, Y, and it can be any size by any size. Okay, so it can be n by m, okay, where it doesn't have to be equal, okay, but only when you're adding and subtracting. But in this context here, we can have any sized matrix. It's an array or a list of numbers in this coordinate format. Okay, think of it as like a column vector, but like an extension of like a column vector.